In today's lesson, we are still working with operations with radical expressions. We've been adding, subtracting, multiplying, and dividing. So we are going to continue multiplying actually, but we're going to look at more complicated examples. Some distributive property, multiplying binomials where we remember how to FOIL, and then we learn what it means to multiply conjugates. All right, so first we're looking at the distributive property with radicals. So our first example, the square root of 3, we can distribute to the square root of 5 plus the square root of 12. All right, so square root of 3 times the square root of 5 is the square root of 15. And then we're going to multiply here. So square root of 3 times the square root of 12 is the square root of 36. All right, so you always are looking to simplify. Square root of 15 doesn't have any perfect square factor, so that will stay. But the square root of 36, that's a perfect square. So square root of 15 plus 6, and you can't combine any further than that. That's your final answer. All right, here is our second example. Square root of 2 times 4 square root of 5. And then we'll do square root of 2 times 3 square root of 10. All right, so for the first one, square root of 2 times 4 square root of 5. So the 4 on the outside will just stay 4 on the outside, and 2 times 5 is 10. So 4 square root of 10 minus, all right, so I've got, let's see, a 3 on the outside. 3 and then 2 square root of 10, that is square root of 20. I always look to see what you can simplify. 4 square root of 10, I can't do anything, but the square root of 20, I can simplify. So 4 square root of 10 minus 3, break 20 apart into 4 times 5. And then the square root of 4 is 2. And 2 times 3 is 6. So 4 square root of 10, I can't break apart the square root of 10, minus, this turns into 6 square root of 5. And then I cannot simplify any further, so that is it. All right, now we're looking at multiplying two binomials where we have radicals. So we're going to use the same method that we would always use for multiplying two binomials, and that is the FOIL method. And then I will also show the box method. So for the FOIL method, we have to multiply the first terms, the outside terms, the inside terms, and the last terms. All right, so to multiply the first terms, I would do 4 square root of 3 times 3 square root of 2. So multiplying the outside numbers, 4 and 3, and then multiply the radicals, square root of 3 square root of 2, that becomes square root of 6. All right, so let's see, outside, let's switch colors here. All right, so the outside terms, okay, so 4 times 6, and it's minus, so minus, let's see, 4 times 6, 24, and the square root of 3. All right, inside would be 5 times 2, or sorry, 5 times 3, 15, and then square root of 2 times the square root of 2 would be the square root of 4. Or maybe you're able to just recognize square root of 2 times the square root of 2 will just turn into 2. But then, all right, so I've got first, outside, inside, and then last. So 5 times the negative 6 would be negative 30 with a square root of 2. All right, so can I simplify anything? So 12 square root of 6. Can't simplify anything there. Minus, let's see, 24 square root of 3. I can't simplify anything there. Well, this would be 15 times 2, which is just 30 with no radical, minus, I can't simplify anything here, 30 square root of 2. So I cannot add or subtract any of those together that I have left, and that is the simplified expression after using the FOIL method. All right, so here we're multiplying two binomials again. You can use the FOIL method every time. The box method is just another method to kind of organize some of your work. What you can do is take the first binomial, and you can write the terms like on the side of a box. So we've got 6 square root of 3. And then this would be a negative 5. And then on the top, I can write the 2 square root of 5 and the 4 square root of 2. And then what we can do is we fill in this box. It's kind of like a multiplication chart. To fill in this box, I'm going to do 2 square root of 5 times the 6 square root of 3. So 6 times 2 is 12. And then square root of 3 times the square root of 5 is the square root of 15. All right, so this box, 4 square root of 2 times 6 square root of 3. All right, 6 times 4 is 24. Square root of 3 times 2 is the square root of 6. All right, this box here, so 2 square root of 5 times negative 5. So negative 5 times 2, that's negative 10, but there's still a square root of 5. And this last box, 4 square root of 2 times negative 5. So negative 5 times 4 is negative 20 with a square root of 2. All right, so you always look to see if you can combine any like terms, or if we can simplify anything. So here, I can't simplify. It looks like everything, all the radicals are fully simplified, and none of the radicals are alike. So I can't combine anything. I just have to write out a long expression here. So, oops. All right, 12 square root of 15 plus 24 square root of 6 minus 10 square root of 5 minus 20 square root of 2. So it's just a big long expression for our final answer. All right, so at the end of the lesson, we're looking at rationalizing the denominator again, but this time our denominator is going to be a binomial. So what we're going to do, this is kind of like a little intro example. So we need to understand this before we can do one where we're rationalizing the denominator. So what I have here are two binomials. I'm going to multiply together, and I'm going to multiply just using FOIL. So, but notice the two binomials are basically the same, except one is minus and one is plus. Square root of 5 minus 1, square root of 5 plus 1. All right, so let's do the FOIL. Let's do first, square root of 5 times the square root of 5 is just 5. All right, outside, I'm going to label this first, outside. So square root of 5 times 1 is 1 square root of 5. All right, inside, negative 1 square root of 5. And then last, negative 1 times 1 is minus 1. All right, what happens? Square root of 5 and the square root of 5 cancel. 5 minus 1 is 4. So when you are multiplying, these are called conjugates. Two binomials that are basically the exact same, except one is plus, one is minus. What always will happen is the outside and inside terms will cancel, and you're left with just the first and the last. So when you have conjugates, you don't have to do the first FOIL, you can just multiply first and last. Radicals cancel, and I'm left with just a regular number. All right, so here's an actual example where we need to rationalize the denominator. So notice I have radicals in the denominator, which we can't have. So we always have to rationalize the denominator. But because of this addition or subtraction, what we multiply by is the conjugate of the denominator. So let's look here. We can multiply by, let's see, I'm going to put this in parentheses. The conjugate of the denominator is going to look just like the denominator, but it's going to be plus. So square root of 3 plus square root of 2. And whatever is on the bottom also has to be on the top. Square root of 3 plus the square root of 2. All right, so the top, what we need to do is 6 times this binomial we're going to distribute. 6 is not a radical, so this is going to look like 6 square root of 3 plus 6 square root of 2. And I can't combine those. Okay, on the bottom, we would FOIL. But what we just found out, FOILing, you only have to multiply the first terms and the last terms. The outside and the inside will cancel. And watch, square root of 3 times the square root of 3, that's just 3. Okay, and then square root of 2, negative square root of 2 times the square root of 2 is just minus 2. Now I don't have any radicals, and 3 minus 2 is 1. So if this turns to 1, well, dividing by 1 is just going to mean I don't even have a fraction. So 6 square root of 3 plus the 6 square root of 2 is simplified after I rationalize the denominator.